The world editor we build is nice. I like it at least. Feels really fast to use, definitely minimizing the number of clicks. But you know what's better than a few clicks? No clicks. Just paste some data there and boom, the world is ready. Today I'll teach you about OpenStreetMap, how to query data from it using Overpass Turbo, and how to parse it in our code. You'll also learn about real-world coordinates, how they work, and the geometry of our 3D world. Get ready because things are about to get real. Get it? Because we use real-world data. No.
Gonna code, debug, and have fun. Coding with Radu, coding with Radu. Gonna prototype and design. Coding with Radu, coding with Radu. Let's code now.
To add real-world data into our system, we're going to be working with the world editor again. So make sure you open index from the world folder this time. And here we're going to add a new button. I'm gonna add it here after the load button. And this one will be calling Open OSM panel. OSM stands for OpenStreetMap. It's where we'll get the data from. And we will have a panel where we paste that data into. I'm gonna use an emoji here for a map so that we know what it is. And define the panel here at the end of the controls, still inside of the controls. It's gonna be a div with an ID OSM panel. And the main thing here will be a text area with ID OSM data container. I'm going to give it a number of rows and a number of columns, so it has a relatively big size. And then a placeholder here so that we can tell the users what to do. Let's close the text area. And now two buttons inside a div. One is going to be the one that actually does the parsing, so Parse OSM Data, that converts the OpenStreetMap data into our structure. And the other one is going to just close the panel in case somebody changes their mind. So close OSM panel. I'll add emojis for these as well. Let's save, refresh. And now if you scroll down, you'll see the panel right here. And we're gonna be moving it from here. We're gonna have it just appear over this place and only when you press the button. But let's move it here first. So in Styles CSS, at the bottom, I'm going to add the field for OSM panel and position it in the center. So position absolute, and now 50% from the top, 50% from the left, and that just moves the top left corner in the middle. So we have to also offset it by translating minus 50% to the left and minus 50% to the top. Save and refresh. And now it's here, but I wanted to block everything else somehow. So I will add here a background color, and it will be a black color, but with some transparency. And then a large padding that will cover the whole screen. Refresh. And it looks okay, but this scroll bar is here now. And we can remove that in the body by setting here overflow to hidden, like this. Now let's have it invisible at first and then appear when pressing that button. So I'm going to add here a style with display none. And now let's implement these functions for closing and opening the panel. I'll do that at the very bottom of the file. First one, open OSM panel, and it will just change the display of the OSM panel to block, and then close OSM panel, and I will change the display of the panel to none again. Save, refresh, and now you don't see it, but when you press this button, it appears, and then when you press this one, it closes. And now we have to worry about this one that does the magic. But let's first learn a little bit about OSM. So OpenStreetMap is this website here, and it contains information all over the world. I'm going to go into Finland, in Joensuu, where I am at the moment, and just show you a little bit. So you can actually export raw data from here. You can use this feature and then select the area that you want to export. But this is going to export everything. And by everything, I literally mean pretty much everything that you see here on the map, not just the roads, which we are interested in, but also Green Star Hotel and many, many other things, like where the border between the river and the ground is. So all the information that you see there is part of this data. And to select just what we want, I like to use this Overpass Turbo website. It has a way of querying just the information that we want. I'll show you. We can type here out JSON that we want in JSON form, and then open some parentheses, and I'm going to type way, highway, and then the next line, bounding box. Notice here the parentheses and the curly braces, be careful. And then at the bottom here, out body greater than semicolon, and out scale for skeleton. So these are technical things. It just means that we want the full body, not a simple summary, and that we want to contain all the necessary information for making the points and the segments between them. And skeleton removes some extra details, some unnecessary info. But you can learn about these by looking at the documentation, and you can also try using the wizard to come up with queries. It can be really helpful. Now, let's see what happens if we press run. It warns me that it's going to be a lot of data. Do you want to continue or not? And I'm going to abort this time, but it will work if you say continue anyway. It's just going to be really, really a lot of data. And it's best that we focus on a smaller section. So maybe here I'm going to focus on this part over the river and try pressing the button again. The warning doesn't come anymore, but you can see that it's still quite a lot of data here. And actually, these contain much more than we need because cars can't go everywhere here. Like here, it's not really possible to go. This is a footway. And we really want only the main roads where the cars can go. We also have here pedestrian walking roads or cycle paths, and it's really too much data here. We need to filter it somehow. And we can do that here by typing what we want to keep, like this. And I'm going to say remove these pedestrian crossings. I'm also going to say remove the footways and the cycleways. like that. So every line is going to remove something. And now when we run, pay close attention what happens here. Many of these went away. The map is much simpler, but it's still not totally simple. Like it has a lot of other things here, like this path and this service and this corridor. So a lot of different things here that we just don't need. And I'm going to type them one by one so that you note what they are. Path, service, corridor, and a bunch of other ones that I just noticed don't look good for me. So in Joensuu, you will find all of these other things as well, and it's possible that I don't cover everything to make it work well in your region. But for me, this gives the best result, something that I really like, and I think that cars would actually go in those locations. And I'm also removing here roads that are proposed, so not created yet. Things that are under construction. There's also elevator. Bus. Guideway. And I avoid private roads or roads that just cannot be accessed. And with this long query here, I'm going to run it. And now it's as simple as I wanted. And notice here when zooming out that sometimes you get some extra things here. You don't get just what is on the screen, but this is normal behavior. And the information that we're going to copy, you can find here inside of the data tab. And we will eventually copy everything from here into our app and parse it to become points and segments in our graph. So let's implement this Parse OSM Data function and check first if the container is empty and warn the user that they should paste data first. Return. Otherwise, if we are here, I'm going to have an object called OSM and give it a function to parse roads, and I will parse the OpenStreetMap data container value here. And then close the panel with the function that we created up here. So the data will come as a string, and then we parse it, and this object is going to become our graph pretty much. I will implement this OSM object inside of a file, and the file will be in the math directory. So let me just copy this graph and call it OSM.js and JS math. Create a new file, OSM.js. This is just going to be an object where we are going to group related functions. I'm only going to teach you how to parse the roads, but you can make other functions here as well if you want to get the actual building locations, shapes, and maybe water bodies. Try looking at the documentation and see if you can make more interesting use of this. So the parse roads is going to get this data. And now let's have a look a little bit at the data here. It looks a little bit cryptic. There are many numbers here. I do recognize some roads, some street names that are here in Joensuu, but the easiest things to recognize are actually at the bottom. They are all of these nodes which have a latitude and longitude. These are essentially points, and the latitude and longitude are coordinates for those points. More on that in a second, but let's first get these nodes. So I'm going to take the nodes by taking the data elements and filtering where the type is the node. And let's log these nodes. Now here, let's copy everything. Go to our world editor, refresh. I'm gonna remove the graph from here and actually also save an empty graph so that every time we refresh, I don't have to do that anymore. And here, open the panel, paste, and pressing this button is gonna list here all of the node items there. And now we have to consider these latitude and longitude.
The world looks like this, and it can be divided like this. These are called lines of latitude. Now, they're not actually straight, apart from the equator, where if you would go in a straight line, you would come back to the same place. The others are not like that. You actually have to turn when following them. Think about it, especially near the pole. You're almost turning in place at that point. So these are actually circles used to emphasize points that are at the same angle away from the equator. The convention is that you have positive values towards the north and negative values towards the south. The world can also be divided like this. These are called lines of longitude or meridians, and they divide the Earth kind of like an orange. That makes them different from the lines of latitude because these are actually straight. If you travel in a straight line along any one of them, you will return to the same place. Now, these also measure angles, but like this. Starting at Greenwich, the prime meridian, the angles are positive and grow towards the east, and negative towards the west. Joensuu is at around 62 degrees latitude and 29 degrees longitude, so you'll see these values a lot coming up.
I will prepare here a points array, and let's loop through all of the nodes one by one and define here y as the latitude of the node and x as the longitude of the node, and see what happens. Now here we push inside of the points array a new point with x and y. And let's set the graph points to these points. We'll refactor this later because it's not nice to use here the global graph. But for now, let's just do this for quick testing. And save, refresh, open this, paste the data, and this is what we get. It looks like we have just one point here, but they are actually several of them overlapping each other. The reason is, if we look here inside of these nodes again, all of these essentially y and x values are 62 something, 29 something. All of them are the same. The differences are in this latter part, and here we just draw them as 62 and 29 pixel pretty much. So all of them look the same. We need to spread them out. And I'm going to spread them out to the size of the canvas next. So let's go here. I'm going to remove this log and extract first just the latitudes from the nodes, like this, and copy this for the longitudes. And now let's get the minimum latitude first by spreading all the latitudes and passing them to the minimum function. and then here the maximum latitude by using max instead. I'm gonna do the same for the minimum longitude with the lons here, and the maximum longitude with the lons as well. And here, instead of passing these, we are going to scale them to fit inside of the canvas. So I'm first going to get a number between 0 and 1, representing how far away from the min-lat and max-lat is this, and then that number between 0 and 1 will be scaled by the canvas height in this case. So to get a number between 0 and 1, according to this node.lat there, I'm going to use the inverse lerp function. So this gives us a number between 0 and 1, an offset from min-lat to max-lat. This is pretty much the same as a normalizing function, but we have used the word normalize for something else. So let's have this one and scale it like that. Now the same thing here with the minimum longitude, maximum longitude, and the node lon times canvas width. Let's implement this inverse lerp in utils.js. I will put it here under the lerp functions, and it's a simple one again. Given a, b, and v, we return v minus a divided by b minus a. This gives us what we want. Now let's save, refresh, open this, paste it here, and we get something. It's zoomed out a bit because of how I saved this previously, but it looks kind of funny. It's upside down, isn't it? These two roads here, I can recognize them here going like that. So let's fix that. The problem is that y grows downwards, so here we can actually flip these max-lat first and then min-lat, and this should solve the problem. Save, refresh, paste here, and now it's okay, but this is made to fit a square canvas, and the data here, it's definitely not square, it's quite elongated like that. So we need to get the aspect ratio of this data to preserve the same aspect. I'm gonna do that here. We're gonna need the difference on the latitude, like this, and the difference between the max and min longitude. And here, the aspect ratio, I'm just going to define it as delta lon divided by delta lat. And the width of the data, I'm going to calculate it with respect to the height of the canvas. So width is going to be canvas height times the aspect ratio. And now we can replace this here. So there shouldn't be any more stretching now. Let's save, refresh, paste it here, and wow. It's a lot of stretching, but in the other way, not as we had previously. What happens here? I'm sure the formula is correct. We don't really understand the differences between the latitudes and the longitudes.
The thing is that while the distance in meters between the latitude lines is always the same, the distance between the lines of longitude changes. 1 degree here at the equator is basically the same, no matter if we talk about the latitude or longitude. But if we move 1 degree east in Finland, we cover about half the distance than if we would move 1 degree north, for example. Why half? Because the circle here has half the circumference of this one here. Why half? Because the circle here has half the radius of this one here. Again, why half? Because the radius here is cosine of the latitude times the radius here, and cosine of 60 degrees is 1/2. So we need to scale by the cosine of the latitude to fix the problem.
I'm going to add here multiplied by the cosine of the max latitude. And I can use pretty much any latitude here because it's a small place, so the differences won't be much. So max lat is just fine. But these are degrees and the function expects radians, so we have to convert it by saying multiplied by math pi divided by 180 degrees. Probably best to extract this as a function, so maybe we say here degrees to radians of max lat, like this. And this is going to be a new function in utils. It is like before, degree times math pi divided by 180. Now save, refresh, paste the data, and this looks just how we want it. And we can actually try connecting points now to make segments here. If I click on these, whoa, this road is really, really thick. So we need to think about scaling this data still, because now the points have the same kind of relationship to each other, but the data should be scaled much more for this to make sense. And we'll go back to OSM.js here, and I will define the height, instead of the height of the canvas, something more meaningful. So height is going to be delta lat times 111,000. And I'll explain this in a second. But height will replace my canvas height and my canvas height. Save, refresh, paste the data, and it's spread out a bit more. But now there is a logic to this. When we are zoomed in as much as we can here, this segment here is going to have some distance, some length. The length of this segment in pixels is going to be the same as the length of this segment in meters in the real world. And that's because 1 degree of latitude is 111 kilometers. So here I'm converting into meters. But our road width is obviously very, very wide. This is 100 pixels. So that would mean this road is 100 meters wide, and that's way too much. So we could scale this by another 10 here, and this would make the road 10 meters, basically. Let's save, refresh, paste the data, and it went somewhere. I have to scroll a bit to find it, but this is more okay. Can see here some nice structure. And if we would connect these points, then this does look like what we expect. Of course, I'm not going to connect these segments by hand like this. We will do it in code. Let's go here and prepare the segments as well. And here our graph is going to return those as well. Let's just prepare for that so we don't forget. And to get these segments, we have to understand the ways. Going back to Overpass Turbo and going somewhere at the top here, these ways mean that a point, a node with ID, this ID, is going to be connected by a segment to this ID, which is connected by a segment to this ID. So every consecutive items here have a segment between them. And these IDs are the IDs of the nodes from here. They do have an ID. So we're going to need to use that in a way. Let's just first get these ways. So again, I'm going to filter a way like this. Let's also log it and debug, save, refresh, paste the data. Here they are. And now let's give these IDs to the points. They don't have them. So going back here, I'm going to extract this point like this. Here's the new point of X and Y, and just give it an ID from the node information, like so. And now this is the one that we pass here. And to connect them, we are going to loop through all of the ways, like this. Take out the IDs, which are in the way nodes. And now we are going to loop through all of them, starting at 1, because I'm going to connect to the previous, always. Going all the way until the end. And let's get the previous point. So the previous point will be find the points with this ID equal to IDs of I minus 1. And we copy this for the current without the minus 1 there. And now with this previous and current point, I'm going to push a new segment into the segments like this. Save, refresh, and before you press this, a warning. This is going to take time if your graph is long. Let's see. This box didn't go away. To me, this acts as a kind of a progress indicator. Everything is stuck at the moment. And it's going to take time to process all of this. The envelopes have to be generated. The buildings have to be generated. The trees have to be generated. Find place for them somewhere that doesn't intersect with all the other things. There's a lot of processing going on here. And it will be slow, even with medium-sized graphs like what I'm using now. But it's done. So did it work? Let's scroll down a little bit. And there it is. This is part of Joensuu, and it's kind of hard to navigate. Like, it's really, really big. We're going to need a mini-map. I'm going to teach you that later. Yeah, some parts are a little funny. Like here, this should be a bridge going over the river. So no houses really. You could get the water bodies from OSM and do something with them, but this is just fine. Now let's refactor a little bit and not use this. So instead of using the graph here, I'm just going to return the points and the segments that we collected there. And in index.html, where we call this function, I'm going to take out the result like this, and then pass the points to the graph points and the graph segments like this. Okay, now this will work. It's just a small refactoring here. One thing I still want to show you is how to get if the segments are one way or not. This is going to be useful if you want to make a route for your car and tell it it's not good to go opposite direction of a one-way street. So in OSM.js, we can check for that here. And my way for doing it is this. One way is going to be equal to way tags one way, or way tags lanes is equal to 1. Now I'm going to pass this one way here, and we need to pass this to the segment as well. So in the primitives, segment at the top here, by default, it's false, but we can set it here like so. And to draw it a little bit differently here, I'm going to modify the dash to make it almost like a dotted line, so we can see the difference. Now, let me go back here and explain this just a little bit. In Overpass Turbo, you will see here some of these ways having one way, and that will be set to yes. You will also see sometimes lanes is equal to 1 here. Sometimes you will see a combination. OpenStreetMap is not very consistent with these, really. And I'm quite sure it might be a little bit different in other places. But it is what it is. And let's take the data once more. Refresh. Paste. And again, I have to wait to see if the one-way roads are showing differently. Now, this is also the reason why we implemented the save, to save the whole thing, not just rely on the generate method, because this would take a very long time to generate if we want to simply load the world afterwards. Loading will be in an instant, but generating this, you don't want to wait for that. Okay. So let's see, I think there should be some here. You can see the lane in the middle is dotted line compared to this dashed line there. And that's because you can only enter this roundabout in this one way, like that. And also exiting it in one way. So now the data is proper. But this interface, even with this medium-sized graph, it starts to lag. At least for me, I can feel it lagging, and the animation is not so smooth when dragging it around. I won't go too deep into optimization, but let's do something here. In World.js, the main reason why this is slow now in the draw method here is this part. There are quite many items and we are sorting them. So linear arithmetic time complexity here, and also drawing quite a lot of items. Of course, drawing everything that is off screen or too far from the viewpoint is pointless, basically. That would be another kind of optimization that you could do, but I'm not going to do all that. I'm just going to show you how to make this one smoother. So let's keep just items that are within the viewport. I'm going to do that by passing here a render radius, a distance to this viewpoint, the middle of the viewport. And beyond that, I won't consider these items. So here, what I'm going to do is I will type filter. So I will just keep some of these items. And I will keep those items whose distance to the viewpoint is less than this render radius. Save, refresh, paste again, and waiting. What do you think of the course? Have you learned something from it? I sure hope so, because it does have a lot of things, and I hope it's not too confusing with so many things, but if you got this far, congratulations. Okay, great. Now, should see something different if I scroll down here. Or actually, we shouldn't see anything different, but I do feel this is much faster than before. So something is happening. It's better. If we zoom out, we actually see what is happening. Only the items that are close to the viewport center here are being rendered. And you probably have seen things like this in many games, for example, that don't render things that are too far away. It's for the same reason, to make things smoother. Okay, but I'm not going to add markers here, but I will put a place for the car to be at. And also a little bit of warning here, if you would like to make changes to the graph, it's gonna be really slow and this interface is not usable, because any small change you make has to regenerate everything. You have some options here. You either make the generation method only update locally what changes you have made, or probably the easiest thing you can do is go here in index.html and just not generate the world, and then save just the graph, and the world will generate once you're ready, or something like that. And only work with the graph. So loading the data from OSM is going to be really fast if you just parse the graph, and then you can play with it. And when you're ready, maybe go to the console and type this, and then it's going to take some time, but the changes will be there. Okay, but here I'm just going to put the car there, maybe keep this viewing angle like so, and let's save this. And saving is going to give an error, at least in my case. This is because local storage is just not big enough for these sort of things. But I did save the world as a file on my computer, and that worked. I'm going to go here to the world main folder and create a new folder next to JS. Call this one saves, and paste this big world into it. And I'm going to show you how to add it into our simulation app next time, because now it can't read it from local storage since it failed.